Very good afternoon, all. Welcome you all back to study with me. It's me, Vidya here. So, we are going to start up with a new topic today. So, that is resistors in parallel. So, we have already studied about resistors in series and we have already solved some numericals on that. So, if you have not checked it out, you can check out the channel, and I have created a playlist also. You can just go through the videos. Now, we'll start with a fresh topic, resistors in parallel. So we already knew that when a resistor is connected one after the another. Okay, if two resistors are connected in this way, one is connected immediately after the other, then we call that this is a series connection. Right, this is what we have studied. But in case of a parallel, two resistors will be connected in this way. Okay, two resistors will be connected in this way. That means this is the starting of both the resistors, right? So the starting points will be connected to a point. Similarly, the ending points of the resistors will also be connected to a particular point, the same point. The starting points will be connected to a common point. Similarly, the ending points will also be connected to a common points. So this connection, this type of connection is called as the parallel connection of resistors. Okay, so when one resistor is connected after another, if there is a continuity in the connection, then we will call it as a series connection. And if both the ends, the starting ends are connected to one point and the ending ends are connected to another point, we call it as a parallel connection. Okay, now let us consider a circuit. Okay, let me draw the circuit. So let this be the resistance R1 and this be the resistance R2. So I am going to connect these two resistors to a common point. Similarly, the ends to a common point B. So let this point be A and let this point be B, and I am going to connect this to a voltage source. Any voltage source V. Okay, I have connected this to a voltage source V. Okay, so this is my circuit. So I have two resistors. This is R1 and this is R2, and the starting points of R1 and R2 are connected to a common point A, and the ending point of R1 and R2 is connected to a common point B. So we have already studied what is potential difference, right? So what is potential difference? The difference in potential between two points is called as potential difference, right? The difference in potential between two points is called as potential difference. So let us consider what is the potential difference of resistor R1. So consider resistor R1. What are the 2 points at which the resistance R1 are connected? The point A and the point B. So how can we find out the potential difference at R1? So we can write V1 is equal to VA minus VB. Correct? Because the 2 points at which the resistance R1 is connected is point A and point B. So we can write V1 is equal to VA minus VB. Similarly, if we find out the potential difference across this resistance R2, we can see that R2 is also connected to the same points A and B, right? R2 is also connected between the same points A and B. So we can write V2 will be also equal to VA minus VB. Correct? V2 will also be equal to VA minus VB. So we can say that both this V1 and V2, that means the potential across R1 and the potential across R2 are same. Okay. So now let us find out what will be the total value. Total voltage. Total voltage is this value. So how is this V connected? This V is also connected between A and B. So if total voltage V also will be equal to what? VA minus VB. Is this clear? So if we find out what is the potential difference R1, so we have to brush up what is potential difference. We have studied that potential difference is the difference in potential between 2 points, right? So when we are considering the resistance R1, it is connected across 2 points A and B. So we can write the potential difference across V1 is VA minus VB. Similarly, if we are finding out the potential difference across R2, R2 is also connected between A and B. So we can write again V2 is equal to VA minus VB. Now if we need to find out the total potential difference of the circuit, This voltage source is connected between 2 points A and B, right? So again, the total voltage will also becomes what? VA minus VB. So from this, what we can write is the total voltage V is equal to V1, which is also equal to V2, right? V1 and V2 all are same. Correct. So what we can say here, in case of a parallel connection, the voltage remains same. Okay, in case of a parallel connection, what happens? Voltage remain same. So we studied that in series connection, voltage gets distributed, but it is opposite in case of a parallel connection. So what are the 2 points to remember? The first point is voltage remains same. What is it? Voltage remains same. And the second point is current gets distributed. Current gets distributed. It is just opposite of a series connection. In a series connection, the current is same and voltage gets distributed. But in case of a parallel connection, the voltage remains same and current gets distributed. So this is the point. So for example, this is the voltage source and a total current I passes through the circuit. So I reaches this particular point A. Okay, the total current I reaches this particular point A. At A, what happens? It is dividing into two different branches, right? It is dividing into two different ways. So this total current gets split up into two currents, I1 and I2. Okay, it gets split up into two currents, I1 and I2. So here what you will get? Here you will get I1 current. Here you will get I2 current. Again, the output of B will be total current I. So is that clear? So the total current I is reaching this point A. At A, it gets split up into two currents, I1 and I2. Again at B, I1 and I2 combines together and the output will get the total current again. So that is why I told that the current is getting distributed. If we have three branches, if we had one more resistor connected like this, we will be having another one current I3. Okay, depending upon the number of branches, the current gets distributed. So I think this is clear. So these are the two main points that you need to keep in mind. The voltage always remains same and the currents gets distributed. Now let us derive a small the equation for finding out the total resistance. Okay, so we knew that currents gets distributed, right? So can we write I is equal to I1 plus I2? Can we write I is equal to I1 plus I2? Because I told you that the total current I is splitting up into I1 and I2. Again here also I1 and I2 combines to form I. So I can write total current I will be equal to I1 plus I2. So we know by Ohm's law. Okay, by Ohm's law. So we know Ohm's law, V is equal to I into R, or we can write I is equal to V by R, right? I is equal to V by R. So instead of I, what can I write? I can write V by R. So this I represents total current. Okay. So therefore I am writing IT. So here I can write it as IT. IT represents the total current. So here I am writing VT means the total voltage and RT means the total resistance. Okay, equal to I1. So instead of I1 I am going to write V1 by R1, and instead of I2 I am going to write V2 by R2. Okay, V2 by R2 by using this Ohm's law equation. So we already know that the total voltage is equal to V1 and V2 all are same. So we can write VT is equal to VT by RT is equal to V by R1 plus V by R2, right? Okay, so here instead of VT I am going to write V. Okay, so I can take out this VT. So it is equal to V by R1 plus V by R2. So here V by RT is equal to, so I am going to take this V outside because both are the common factor. So 1 by R1 plus 1 by R2. So this V and this V gets cancelled and I will get the equation as 1 by RT is equal to 1 by R1 plus 1 by R2. So this is the equation to find out the total resistance in case of a parallel circuit. Okay, what is the equation? 1 by RT is equal to 1 by R1 plus 1 by R2. So if we are having 3 resistors, you can write plus 1 by R3. So it goes on. If you are having 4, you can write plus 1 by R4. What was the equation for in series? RT is equal to R1 plus R2. Okay. So these are the two equations that you need to keep in mind. And keep in mind, this is a very important 3-mark derivation for your board exam. Okay, so the thing is, current gets distributed. So total current is I1 plus I2. So VT by, instead of I, by using Ohm's law, I'm going to write I is equal to V by R. So here I represents the total current. So I'm going to write total voltage by total resistance is equal to I1 is V1 by R1 and I2 is V2 by R2. So we know that in case of a parallel circuit, the voltage is same, right? So we can write Vt is equal to V1 is equal to V2, which is the total voltage. So instead of Vt, I'm going to write V. Here V1, again V, V2 is also V, because all are same. So here I'm taking in both from these two variables, I'm taking V as a common factor. V and V gets cancelled, and finally I'll get 1 by RT is equal to 1 by R1 plus 1 by R2. So this is the equation to find out the resistance, equivalent resistance in case of a parallel connection. So hope this is clear to you. So always keep in mind these two important points. In case of a parallel connection, the voltage remains same and the current gets distributed, and the equation to find out the total resistance or equivalent resistance is 1 by RT is equal to 1 by R1 plus 1 by R2 plus etc. up to how much resistance they are connected in parallel. Okay, hope this is clear. So that's all for today's lecture, and we'll do some numericals on this part in the next lecture. So till then, take care all of you. Bye bye.